Welcome back to Robominions.in AI interview preparation app. The topic of this video is generating binary search tree, and I repeat this in every video. You have this arrow, it goes to the specific code execution line. So wherever the code is getting executed, it goes to that line of the code. So it's perfectly synced, and because the AI does all the work for you, so you just have to do back and next button. The code is in with your control at every single stage. You can just see when I click next. If you want to go back, you can just click back and it goes back. So it's a well designed code tracing tool. Okay, so when we then yeah, now we have included hash include stdlib.h. Then we have hash include stack features.h. The stack features.h has already been, this part of the code has already been explained in the video DSA32 stack implementation using linked list. Please watch that video, DSA32 stack implementation using linked list. There in that video we have explained this part of the code. This will give you the stack operations like push pop, stack top, and is stack empty. So these are used for the generating the binary search tree. Yeah, now you can see here a stack dt is segment is allocated. Then we have a void create bst from preorder function declaration. Then we have node underscore bst pointer, type with a root pointer equal to null. Then we have a preorder underscore ar array. So it has a preorder traversed data. So the BST preorder data is available, that is 11, 9, 8, 22, 18 and 40. So we have already seen a binary search tree with this data in the previous videos. So we have generated the preorder from that binary search tree. Then we have int n equal to 6. Then we have when we go to the void main. Then we call the function create bst from preorder. So we go to the void create bst from preorder, int I equal to 0 here. Now we have root equal to new node create. We send the address of that I. So new node create will receive that address in the pointer I, and we create a new node here. New node has been allocated with a memory with a type of node underscore bst. So it has been node has been allocated. This node underscore bst structure has left child, right child, garbage value, and node garbage value as a data. So memory has been allocated. Next we have new node data equal to preorder of star I, and then we increment it. Right now the I star I, that is the pointer, is accessing the value of I. So value of I is 0. So preorder of 0 is 11. So 11 is assigned to the new node data. Okay. Then we have left equal to null, right equal to null, and this returns, and this function returns the new node back. So we have root equal to, it has returned the new node. Now we are creating another pointer node underscore a. Then we have node underscore b equal to root. So that is pointing to the same node. Then we have while I less than n. I is right now, after here I has been if I go back, if I go back, keep watching. When I click next, I has been incremented because we have star of I plus plus, that is the pointer accesses the value and it has incremented the value. So I is equal to 1. Now if I go back to the function call, root is assigned, then node back, and then we are here in the while. Now I has been incremented in this function. So 1 less than 6 is true. Now as the while condition is true, it goes inside the while condition. Here we have pre-order underscore array of I. I right now is 1. So pre-order underscore array of 1 is 9. So 9 less than node underscore b data. Node is underscore b is pointing to this node. So the data of this node is 11. So 9 less than 11 is true. It goes inside the if condition. We have node a equal to, we again call the new node creator function and pass the I address. So when I call that, so we have new node equal to, a memory has been allocated with the type node underscore bst pointer. The size of node underscore bst structure is sent to the malloc and that much memory is allocated. Now new node data equal to, we have pre-order of star I that is value of the I, that is 1 right now. So pre-order of 1 equal to, it is 9. So 9 is assigned to the data. Okay, new node data, new node left equal to null. So right now when if I go back, that's here I is 1 right now. When I click next, I has turned 2 because there is star of I plus plus. So I is incremented to 2. You have to remember this. Just keep watching, have a clear picture, like watching all the data on the screen. So keep a track of all the data on the screen. Okay, now new node left equal to null. So new node left is null, new node right is null, then return new node. So that new node is returned to node underscore a. So it has node underscore a has a now pointing to hash 200. Now node underscore b is pointing here, left equal to, node underscore b left equal to node a. So hash 200 has replaced the null. Null here has been replaced with hash 200. Now you push node b. So node b address is hash 100, data is 11. So the node b address is pushed to the stack. This is a stack address stack location address 900, but the data in the stack is hash 100. The address of this node has been pushed to the stack. Okay. Now node b equal to node a. So node b has come here to node a. Done with the if condition. So now we have again checking the while condition. Right now I less than n. I is 2. I hope you remember I was incremented, right? So now I is 2. N is same 6. 2 less than 6 is true. Now we again go to the inside the while condition. In the if we check pre-order underscore array AR of 2. AR of 2 is 8. 8 less than node b data. Right now node b is pointing to this node. That is 9. 8 less than 9 is true. We go to node A. Now node A, again a new node creator function is called inside this if condition. We pass the address of I. So when I click next, a new node is created with a memory is allocated using malloc. Malloc is available in std_lib.h. Okay, memory is allocated. New node data equal to pre-order underscore AR of 2, because I is 2 right now. So star I will be 2. So pre-order underscore AR of 2 is 8. Data 8 is inserted to new node data. So that has been inserted. Now when I click next, I has been incremented because it was a post increment. I has been incremented. Now new node left equal to null. So new node left is null. New node right is null. Now return the new node back to node A. So new node A is now pointing to hash 400. Now node B, next step, node B left. You see node B left is right now null. It has to point to node A. When I click next, you see it has changed. Hash 400 has been copied. Now we again push this node B, push the node B to the stack. Hash 200, the address of node B has been pushed to the stack. The bracket data, right, 9 and 11 is for our reference. We have put for our reference, but in the computer, when it pushes to the stack, it only pushes the address that is hash 200 and hash 200, the address of node B that has been pushed. Now node B equal to node A. So node B equal to node A. So node B has come down to this node. Done with the if condition. Now again while is checked. Now this time I is 3. So 3 less than 6 is true. It goes to the preorder underscore AR of 3. AR of 3 is 22. 22 less than node B data. Node B data is 8. You can see node B data is 8. 22 less than 8 is false. It goes to the else part. Now again it checks. Preorder of 3 is 22. 22 is greater than node B data. 22 is greater than 8. That is true. Ampersand. 22 less than, in bracket we have a condition. So is stack empty? Is stack empty? No, it is not empty. So that will return 0. Is stack empty? Return 0. And we have a larger value 3. So if stack is empty, then it should have returned 32767. Now stack is not empty. It returns stack top data. Stack top data. Stack top address is hash 200. Hash 200 is this node, and the data of this node is 9. So so it has, so this condition stack empty question mark 32767 colon 9. So for false condition it has given 9. So 9. So 22 is less than 9 is false. So it is false and false. So this condition becomes false. It goes to the else part. Just rewatch this part if you want, and or write it on a paper. You can clearly see 22 is preorder AR of I, that is 3. 22 is here. Then node data, node right now is pointing to this node, data is 8. Then we have and preorder underscore AR of I, that is again 22. 22 less than is stack empty is called. You can see stack is not empty. Is stack empty has returned 0. Then we have a question mark. So if is stack had returned true, it would have selected 32767. False, it will select stack top data. Stack top of the stack is hash 200. Hash 200's data is 9. So arrow operator data. So 9 is selected. 22 less than 9 false. 22 greater than 8 false. So this condition is false. We have come to else part. Okay, I hope you are with me. Now node B equal to stack top. Node B is hash 200. So node B has gone and pointed to this node. Then we do a pop operation. The node has been popped. You can see it has been popped. Then end of the if condition. Now again we check the while condition. While I less than n, I has remained same. 3 less than 6 is true. Okay, and now we have again the checking if preorder underscore AR of 3, that is 22 less than node B data. Right now node B is pointing to 9. So that is 22 less than 9 is false. It goes to the else part. Now in the if condition, again we have 22 greater than 9 for it's true, and 22 less than is stack empty. Oh, I just remember in the previous section when we hit this part of the code, 22 greater than 8, I said false. So please correct that. 22 greater than 8, the previously 22 greater than 8 was actually true. True and false was false. So in this case too, 22 greater than 9 is true, and 22 less than is stack empty. Stack is not empty, so it has returned 0. So question mark, it has selected 11. So stack top data, stack top is 100, hash 100, hash 100 is this. So data is 11. So 11 is selected. 22 less than 11 is also false. So 22 greater than 9, true. True and false is false. Comes to the else part. Now node B is equal to stack top. Stack top is which data? Hash 100. So node B is now pointing to this node and it pops the stack. Stack has been popped. Again, end of the if else condition, and comes out and checks the while condition again. Now again I is not incremented yet, so I is 3. So 3 less than 6 is true. Goes to the if condition, preorder underscore AR of 3 is 22. 22 less than 11 is false. Comes to the else part. Now we have 22 greater than 11. 22 greater than 11 is true because preorder of 3 is 22 greater than node B data. Node B is right now pointing to this node. Data is 11. 22 greater than 11 is true. And 22 less than is stack empty. Stack is empty, so it has returned 1. So large data 32767 is selected, and stack top data, right now the stack is empty. The stack top data would have returned -1. So but for we have is stack empty question mark, right? So one question mark, one is a true condition. So 32767 is selected. 32767 data, a large data, is greater than 22. So it's just a hard coded data for reference. So large sum is used. So it is greater than 22. The condition has turned true. It goes inside the if condition. Now node A, we are creating a new node. So new node creator is called, function is called again. So goes to new node creator. We have a new node pointer allocated with the memory. So both new node A and a new node are here. You can see memory is allocated with the garbage value. Now new node data equal to preorder underscore AR of 3. So AR of 3 is 22. 22 data is inserted to the node, has been successfully inserted. Now when I click next, I gets incremented because there is a post increment. I has been incremented. Now new node left equal to null, new node left equal to null, then new node right equal to null, new node right equal to null, then return new node to node A. So node A has received the newly created node. Now when we do, now we have node B right equal to node A. So node B right equal to node A. No, so hash 300 has been copied to node B right. Node B is presently pointing the root node. Yeah. Okay. Now node B equal to node A. So node B and node A are pointing to the same node. End of the else condition. Now again while is checked. Now while condition, I is 4. 4 less than 6, true, comes inside the if condition. Comes to the if condition, we have preorder AR of 4. AR of 4 is 18. Preorder array of 18. And the node B data. Node B is right now pointing to this node, that is 22. 18 less than 22 is true. So node A equal to a new node creator function is called again now. So when I click next, it goes to the new node. So new node and memory is allocated with a garbage value. Now new node data equal to preorder of 4. Preorder of 4 is 18. You can see whichever data is added to the binary search tree, it has turned green. Not yet added is still 40. Okay, so please remember that. So 18. Now after when I click next, so 18 has been added, and I click next, I gets incremented. Now I equal to 4, I will become 5. So I has become 5. New node left equal to null, new node left equal to null, new node right equal to null, and return new node to the node A. Node A has got the address of hash 600. Node B left, node B is right now pointing to this node. So node B left is null right now. So now it will be pointing to node A in next step. When I click next, see it is pointing to hash 600 is now is pointing to node A. Now we push the node B to the stack. So it has been pushed to the stack. Hash 300 is the node B address has been pushed to the stack. Now node B equal to node A. So node A and node B are pointing to this node. End of the if condition comes to the end. Now while condition is checked. While 5 less than 6 is true. 5 is less than 6, true. Again goes inside the if condition. If preorder of 5 is 40. 40 less than node B data. Node B data is 18. 40 less than 18 is false. Comes to the else part. Now in the if we have in the if condition next in the else part we have preorder of 5 because I is 5. 40 greater than 18 is true. Okay. Then we have AND condition and 40 less than is stack empty. Stack is not empty. We have a address hash 300. Address of this node is there in the stack. So is stack empty returns 0. It has returned 0. Question mark we select 32767 or we select 22. What is 22? Stack top data. Stack top is hash 300. Hash 300 is this node. Data of this node is 22. So 22. For 0 false condition we select 22. Is 22 greater than 40? No, it is not. It is false. That is the reason this condition becomes false. True and false is false. It goes to the else part. You see it has gone to the else part. Node B is equal to stack top. Node B is now node B equal to stack top. Stack top is what? Hash 300, right? So node B has got the address of this node, hash 300. Now we pop the stack again. Stack has been popped. Comes out of the else part. Now again while condition is checked. Now still I is 5. 5 less than 6, true. Now again it goes to the if condition. Preorder of 5, 40 less than node B data. Node B is right now pointing to this. 40 less than 22 is false. It comes to the else part. Now here we have if preorder underscore AR of 5 is 40. 40 greater than node B data. Node B data is 22. 40 greater than 22 is true. Then we have 40, that is preorder underscore AR of 5, that is 40 less than is stack empty. Stack is empty. So 1. Stack is empty, true. So 1 question mark. Then we have two selection option. 32767 a default value, a large value, colon -1. So -1 is coming from stack top data. Since stack is empty, stack top data will return an invalid -1 value. So but the condition is 1 question mark. So it selects 32767. 32767 is greater than 40. So 32767 is greater than 40. So this is also true. So true and true is true. Comes inside the if condition. Now node A is equal to new node create passing ampersand I, address of I. So again we have a new node creation here. Node A equal to new node. So memory has been allocated now at hash 700. Now new node data equal to preorder underscore AR of 5 because I is still 5. So data is 40. 40 has been added to the node. And in the next step, I gets incremented. I has been incremented to 6. And then we have new node left equal to null. New node left is null. New node right is null. Return new node. Return new node is hash 700 has been returned to node A. Now node A is pointing to this node. Now node B, right, node B, when I click back, okay, right now node B is pointing to this node. Node B right is this right is null. So that will be allocated with address hash 700. And I click next. Node B right is now 700 hash 700. Node A address has been added. Node B equal to node A. Node B equal to node A. Both are pointing to the same node. Comes out of the condition, we have end of the while. Now again while condition is checked. While 6 less than 6, that is I less than n, I is right now 6, n is 6, 6 less than 6 is false. All the data has been added to the, comes out of the while condition. All the data in the pre-order array has been added to the binary search tree. That is the end of the create BST from pre-order. So we have successfully created a binary search tree from pre-order, and the time complexity, as we are going through each data and adding to the tree, binary search tree, the time complexity is order of n. To access the code, you can click on the code button here in the app Robominions.in AI interview preparation app. So to explain this, I took like around 30 minutes, right? So what you can do is download the app Robominions.in AI interview preparation app, and by just clicking back and next button, you can revise this concept yourself and explain it to yourself how this binary search tree is getting created using the pre-order traversal data. So it was you can see how you can clearly get the control over the code and see how the stack data is getting changed, how the addresses are changing of the left and right address. So that is the beauty of this AI app. So the artificial intelligence app gives total control of the code to you, so that you can click back and next button and control the code. Okay, I hope you like this video. Thank you guys. See you in our next video. Thank you. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.